Hello everyone. In today's session, we will explore how Terraform Workspaces empower you to seamlessly manage multiple environments, enhancing your infrastructure deployment work. So these are the table of contents which we are going to learn today. So let's start. So what is Terraform? It is an open source infrastructure as code software tool where you define and create resources using providers in the declarative configuration language. Example, JSON. With Terraform, you can package and reuse the code in the form of modules. It supports a number of cloud infrastructure providers such as Amazon Web Service, Microsoft Azure, Google Cloud Platform, etc. So, what is Terraform Workspace? So, Terraform Workspace is a very logical concept where you can use multiple states of your infrastructure configuration. So, to put this in simple words, if you are running an infrastructure configuration in development environment, then the same infrastructure can be run in the production environment. So the main benefit of Terraform workspaces is we can have more than one state associated with a single Terraform configuration. So if you have not defined any workspace, then there is always a default workspace created by Terraform. So you can always work in default workspace of Terraform. So you can also list the number of Terraform workspaces by running the command Terraform workspace show. And also you can delete the default workspace. So applying Terraform workspaces across environments. The first is development environment. So the purpose is to customize model for rapid development and testing. So in this development environment, we use smaller instance type and enable debugging feature for faster iteration. For example, instance type in development environment we can take as t2.nano as per our requirement. And in staging environment, the test integration. The purpose is to test integration with realistic configuration. So example, in the staging environment, we need to adjust configuration for larger instance types and use realistic resource setting. Here we can use instance type as t2.micro. And in production, the purpose is to emphasize high availability, scaling, and security. For example, in the production environment, configure modules for larger instance type, auto scaling groups, and security measures. So here we can use m4 dot large instance type. So according to our requirement. So what are the benefits of using Terraform workspaces? Isolation of environment. So just imagine a scenario when managing development, testing, and production environment. So the benefit of using Terraform workspace will allow for the creation of isolated environments, ensuring that changes made in workspace do not impact configuration in the other. So this isolation minimizes the risk of consequences during development and deployment. Efficient state management. So when simultaneous development efforts across different branches or features, then the benefit would be it will maintain a separate state file, preventing conflicts when multiple developers or team are working concurrently. So this will ensure that changes in one workspace do not interfere with the state or another. Simplified configuration switching. So imagine a scenario where testing and validation of configuration has been done across various environments. So the benefit of Terraform Workspace will make it easy to switch between different environments, allowing developers and operators to quickly test and validate the changes. Parallel development and deployment. So imagine a scenario where development of features or it fixes in a parallel without impacting the main code base. So the benefit would be it will enable the parallel development by allowing separate instances of the same infrastructure to be managed independently. So this feature is particularly valuable in scenarios where different teams or developers are working on distinct feature or changes simultaneously. We can customize our configuration. So tailoring our configuration for specific use cases or requirement. So the benefit will be each workspace can have its own set of variables, allowing for customization of configuration based on specific needs. So this flexibility enables the adaptation of infrastructure settings such as scaling, parameters or resource configuration for different environments without affecting the main code base. The Terraform Workspace provide a versatile and efficient approach to manage multiple environments, offering a range of benefits that contribute to a more organized, secure, as well as scalable infrastructure deployment process. So what are the potential drawbacks of using Terraform Workspace? Code-based code-based complexity. So for example, growing complexity in the Terraform code base as the number of workspace increases, potentially leading to difficulties in maintaining the consistency. Limited to remote backend. For example, dependency on remote backend for optimal functionality, limiting flexibility for teams restricted to local backend. Potential for misconfiguration. For example, it is risk of misconfiguration and unintended changes when switching between workspace frequently. It can also increase learning curve. So introduction of additional concepts may contribute to a steeper learning curve, and especially for new teams new to Terraform or infrastructure as code. Limited resource support. For example, some resource may exhibit limitation or unexpected behavior when used across multiple workspaces and necessitating careful consideration. State file management challenges. For example, managing state file becomes critical and accidental modification or deletion can result in issues across environment. Dependency on Terraform version. Workspaces may behave differently across Terraform versions, requiring careful consideration when upgrading or downgrading. Potential for workspace proliferation. For example, risk of creating numerous workspaces without clear guidelines, leading to confusion and increased operational overhead. Mitigating these drawbacks involves establishing best practices, comprehensive documentation, and ongoing training to ensure effective and efficient use of Terraform Workspace. So this can be resolved. So what is the main difference between the Terraform Workspace and the Terraform module? So the Terraform Workspace and Terraform modules are two different concepts that serve different purposes in the Terraform ecosystem. So workspaces basically allow users to manage different sets of infrastructure using the same configuration by isolating state files. On the other hand, models have logical container for multiple resources that are used together, facilitating reusability and better organization of your code. Now we will implement simple practical to understand Terraform Workspace. So this is the structure of a folder. So now we will create a new Terraform workspace. So before that, I have created a folder called as Terraform Workspace example, and in that folder, I have created main.tf file. So in main.tf file, I have written the code. The provider name, as you can see, is AWS, and the region I am currently using is AP South 1, which is Mumbai, and the profile is set to default. So here we are simply creating an EC2 instance across different environments. So as you can see, there are two files named dev.tf_vars and test.tf_vars. And in variables.tf file, we have simply created a variable called as instance type and type is equal to string. And in main.tf, we have used locals where we have declared instance type as Terraform workspace hyphen instance. So here it will define the local variables, and in this case it will create a variable named instance type, and with the value of the, as you can see, this dollar sign and Terraform workspace instance, so it will build in the variable in Terraform representing the current workspace. So for example, if we are using the environment called as dev, which is means development, so it will use, as you can see in dev environment, I have set the instance type is equal to t2.nano. So in our main.tf file, when we are working with the development workspace, so it will take the instance type as t2.nano. And while working with test environment, so it will take as instance type as t2.micro. So I have created 4 Terraform files. Now we will create a new workspace. After creation of this Terraform files, now we will create workspace. So just open an integrated terminal and just type Terraform Workspace show. So as you can see, this is our default workspace. So our default workspace has been running. So now we can simply add our workspace. So type Terraform Workspace new dev. So it will add a workspace name as dev. So as you can see, we have successfully created and it has been switched to workspace called as dev. So if we do not define any workspace, the code will run on the default workspace. So as you can see, after creation of workspace, here you can see the Terraform state files of the dev. And after creating another workspace called as test. So as you can see, we have created another workspace called as test, and it has been successfully created and it has been switched to workspace test. So now to list out the workspace name, just type Terraform workspace list. So it will give all the Terraform workspace list. So as you can see, we have created two environments called as development and test environment. And there is also by default workspace. So now you can see the star sign before the test. So this is to represent that we are currently in which workspace. We are currently in which workspace working. So as you can see, the star represents that we are currently in test workspace. Now, if you want to select the first workspace we have created, which is dev, so just type Terraform workspace, select dev. So as you can see, it has been successfully switched to workspace dev. So now we will just confirm this by just typing Terraform workspace show. So it will show that what is the workspace we are currently working with. Now we will use workspace in our Terraform configuration. So as you can see, I have simply created an EC2 instance where I have taken the resource name as AWS instance and the name is EC2 example, and the AMI ID which I have been used as operating machine ID, which is Ubuntu, and the instance type has been declared to var.instance type, and the tag name I have taken as local.instance name. So for example, if I am currently working with Dev workspace, as you can see here, so it will create an instance in my Dev workspace. And if I currently switch to test workspace, so it will simply create an instance in the test workspace. And so now we will simply deploy our configuration in AWS. So first, just type Terraform init to initialize our configuration. So as you can see, it will initialize the required provider plugins. So as we can see, Terraform has been successfully initialized. Now we will clear this and we will check Terraform in which workspace we are currently working with. So just we will check that. So Terraform workspace show. So it will show our workspace. So as you can see, we are currently working in Dev workspace. So as we have created dev.tf so we need to create an instance which has type t2.nano. So now we will just type Terraform plan. So here in article, here you can see just we need to type this command. So this will initialize the infrastructure execution plan and our var.file is equal to dev.tf vars where we have stored our instance type will be initialized. So now let's try this. So as you can see Terraform plan -var file is equal to in double quotes our tf1's file. So it will plan for the dev environment. So just click enter. So as you can see 1 to add, 0 to change and 0 to destroy. So the Terraform plan will give what are the resources which we are going to create in AWS. So here you can see the instance type is set to t2.nano according to our requirement. Now we will simply type same command, but now we will type apply. So it will apply our configuration in the AWS. So just type yes. So our resource has been created successfully. Just ignore this error. This is due to the internet connection. And you can confirm this that the application has been applied in our AWS console. Just we need to go into EC2. Just type search in EC2 and just click on EC2. So this is the dashboard and you can see the instance running. So here you can see our dev instance, and by clicking on the checkbox or the instance ID, it will the instance has been created successfully and it will give an public IP address for connection. And here you can see the platform which I have currently used is Ubuntu and the AMI ID which I have mentioned earlier for Ubuntu. So now this instance, so as you can see the instance type is t2.nano. So this instance for was my dev environment. Now I will create an EC2 instance for my test environment where my requirement is that I should have instance type as t2.micro. So now let's try this. So just type Terraform Workspace show. So it will show the current workspace you are working with. So we have created instance on dev environment. Now we will list out the workspace just for understanding. So as you can see, the star mark is before for the dev environment. Now we will simply select our test environment. So Terraform Workspace Test. Select Terraform select test. Workspace select test. So now as we can see, we have successfully switched to workspace test. So now we will simply plan for our test environment. So just type test in place of dev. So as you can see, if we plan our configuration, so here you can see one resource is to be added and the instance type will be t2.micro. Here you can see. Now we will just apply our configuration. So just type apply in place of plan. So it will apply our configuration on AWS console and it will create a resource EC2 instance with instance type t2.micro. So just type yes. So as you can see, EC2 instance has been creating state. So as you can see, our apply has been complete for this time. So here you can see one resource has been added 0 to chain and 0 to destroy. So now we will confirm this by simply click on instances on AWS console and here you can see the test instance has been running successfully and just click on instance ID and here you can see the public IP address for the test instance and the instance type is t2.micro. So here you can see the platform is Ubuntu AMI ID and all the details of the instance. So now to destroy, simply type destroy in place of apply. So just type destroy and it will destroy all the resources created in the test environment. So now let us destroy the resources from the dev as well as test environment. So enter a value, type yes. So it will destroy the resources. So as you can see, our destroy has been completed for our test environment. So we will just confirm this. So here you can see our instance has been destroyed successfully. So here you cannot see the test instance, and it is the instance state is terminated successfully. Now we will apply this for our dev environment. So now we are currently working with the test environment. So just select Terraform Workspace, select the environment. So we have switched to this, and we will just type destroy Terraform destroy dev.tf. So it will destroy our resources. So just type yes. So as you can see, one resource to be destroyed. So here we can see our destroy has been completed, and we have destroyed our resource EC2 instance successfully. So this was the example for Terraform Workspace where we have created an EC2 instance in dev as well as test environment successfully. So if we want to delete a workspace, we need to type simple Terraform Workspace. So we will just list out the workspace we have currently. So we are currently using dev environment. So we will just delete the workspace named as dev. So just type Terraform Workspace delete and the name of the workspace, which is dev. So if you want to delete a workspace, so you need to switch to another workspace as we are currently with using the dev workspace. So we will now just switch to test environment or test workspace. So we have switched to workspace test. Now we will delete dev. So as you can see, we have successfully deleted the dev workspace. So this is the method for deletion of workspace. So we will conclude for today. So in conclusion, Terraform Workspaces empower streamlined and efficient management of diverse environments. So the isolation, state management, and customization capabilities enhance control and flexibility, offering a robust solution for managing multiple environments seamlessly. So for reference, you can visit the official website of Terraform, which is Terraform Registry. And if you have any query, please contact us. And thank you for watching. If you enjoyed the video, don't forget to like, subscribe, and hit the bell icon for more content. And feel free to leave your thoughts or suggestion in the comments. We'll see you in the next video. Thank you.